morning. Welcome to my session today, talking about trends in data technology. My name is Boris Bialek. I'm the head of innovation in Europe, Middle East, Africa at MongoDB worldwide. When we take a look at data today, data are normally problems considered to business in all kinds of shapes and sizes, but as well as they are problems for developers. When developers talk about data, it's always a big area of discussion. It's all about what velocity can I achieve? How much data can I move through my system? How can I deploy my system? How much can I move my data? And what model do I have? How do I scale? What's the performance? Specifically, when you take a look today, people start on very, very small infrastructure, kind of the infamous ramen systems, and then you move up to larger infrastructures to 100 millions of users within weeks or months. And then obviously privacy of data is a big, big thing today. It's not anymore, I store it and, well, if I get a breach, I get a breach. Nobody can afford that. Companies go bankrupt over that one. So when we take a look what today's data problems are, there's a funny thing. It's starting actually in the 1960s, and I put that slide together, and some people say, oh my God, the dude is really old. Yes, I am. But when we take a look, the IBM 3X systems, the RPG systems, these were the first record-based systems at that time, came out in the 70s, and they have a lot of cool features. But really the breakthrough for data came with Codd's model 50 years ago by now, and the articles over relational tables, which made a lot of sense then. But if we are a little bit ferocious here, since Oracle 6, since the block mastering and all the work around Oracle Parallel Server, not much really happened in relational databases. I'm pretty sure people who look at Oracle 20c or other databases who are actual right now will probably disagree, and there's so much cool single features. But if you take a look, the underlying core values about availability, tables, table management are the same. The indexing structures, yes, you have additional things on top. You have now in 20C something called Soda, which is really a bad option of getting simple documents loaded into a system. But the result of all these things is at the end, you stuff it into a table. And interesting enough, over the years afterwards, since the 2000s, several kind of approaches were done. First came the object-oriented databases, then came XML, which I was part of as well, admittedly, and that felt horrible when you look how complex XPath and XQuery can be done. This was typically what happens if peer research people try to define something what a developer has to use. And then came the mega backlash, and everybody went into Cloudera, Hortonworks, and Hadoop. Hadoop was freedom for everything. I can store whatever I want. I can store how much I want. Money is no object anymore because the stuff is dirt cheap. Save me all the data. My joke about that one is, you get a lot of data in and you never get data out. After that one came the other side, which said, well, we need more specialized things to do that one. And the term NoSQL was born, which was starting with not SQL exclamation mark, then became NoSQL, and basically by now is, well, we're doing things differently. But the key part came out of the MongoDB side to acknowledge there are good things in all the things which came before, and recognizing the value of the earlier solutions, bringing things like a schema validation, bringing things secondary indexing, bringing things like transaction and data typing, which led to the multimodal data as a service model, what you have in the most advanced versions of MongoDB Atlas today, or as a MongoDB Enterprise Advanced Server on premises. So at that point, I put a little bit in the corner, future of Hadoop question mark. I'm not so sure. My statement normally is, yeah, to be honest, now you have S3 buckets, you have things like the Mongo database lake. There are other options out there. Honestly, Hadoop for me is dead, but I'm sure there will be people with different opinions on that one. When we take a look to the evolution where MongoDB went through, I would like to refresh a little bit the points. When I started with MongoDB, it was version 3, early version 3. I was working for a financial vendor at that time, and we started utilizing it, and it started just to shape up with advanced aggregations. And when we do fast forward to today, 2020, then we see things really hedged reads, mirrored reads, global distribution, distributed transaction. So we have hundreds of developers and engineers actually working in MongoDB, and people forget that one. MongoDB is an open source database, but We actually pay our developers. We have a development roadmap. We have a plan how we move forward. And we have by now probably one of the largest, if not the largest team in a database development organization around the globe for a single product. When we take a look on MongoDB adoption, I would like to point out we have more than 100 million downloads. We have up to 7 million downloads a month these days. This is pretty amazing. And we see about up to 47, probably by now, the slide is already 4 weeks old, 50,000 new Atlas instances. These are instances what people utilize for commercial purposes. These are not the free ones, what we do. We have literally over 1.5 million students enrolled who are using our systems, and we have 18,400 paying clients. I put some of the Scandinavian clients on the right side, not in order of importance, simply to list from car manufacturing, wireless car, future technology, material logistics, IKEA retail, AMA Sports, which is technology and retail as well, Visma banking, and ERP and Nets for as probably the best known entity in Scandinavia as payment service provider. We are really having a broad range of clients today. We are listed as a most wanted database many times running by now. We are the only really high-end player by now on the DB Engine's rankings. I'm really proud that we surpassed the DB2 organization from IBM, which was my predecessor for 15 years, and MongoDB Realm, our mobile database for iOS and Android, and Raspberry Pi if you want to play with it. It's really cool for edge devices. When we take a look at what MongoDB does and where the trend's going, it's less and less about, oh, we have a database. Yes, can you do best of breed, all the 12, 15, 20 products? But to be honest, what you want to come down to is driving the direction which was started with relational, where you say, look, I can standardize on something, but the difference is to acknowledge the differences for the different data types. So we have at the core a multi-cloud, multi-platform, on-prem, hybrid, private cloud, any public cloud, platform, security. These are the fundamentals, the table stakes. We have MongoDB as a core database here in its instance for the cloud as Atlas, but as well on premises, integrated with the search capabilities and the Atlas data lake. I had several people ask me, can I not do the Atlas data lake yourself? Yes, you can, but you have to rebuild the whole S3 bucket infrastructure and everything surrounding that one. Maybe not really, but we have on-premises options as well. Then we have the developer services on top, where we look into the space of access, how do we manage data, how do we do serverless functionalities, charts for visualization, multiple large number of SDKs actually, ranging from Kubernetes on one hand for administration REST API to the other side on Spark and BI SQL connectors. Then, of course, our edge to cloud sync mechanisms, the Realm Connect and the Realm mobile database. Nonetheless, that is really the core engine level. There's a lot of stuff on top. We're working with business partners for the government's dictionary lineage, be it as INEA, be it in Ab initio, be it for retention, IBM Optim, and compliance there, be it Iguazio, where you will hear some more in another session, which we have as well coming up on the next days. And then obviously consolidated APIs and serverless interfaces like Hazelcast, Gigaspaces, and so on, who we partner with. So it's really important for us that we have a unified experience for developers in the business, which means you have one platform, Translytics, where you have no data duplication. You drive your data through the whole infrastructure, what you need, but you have one data set and you don't need to do things twice. I have to bring up the word of transactions, because this is one of the things where I get challenged pretty much every week upon, and it's kind of interesting. MongoDB is asset compliant since 2015. We can say 2014, 2013, but to be honest, MongoDB 3.2 was really a major milestone in that regards, where documents are really transaction safe, Wired Tiger storage engine came into the mix, we have audit trails, so a lot of stuff happened since then. It's kind of the big flock in the ground. We're the only database by now today since 4.2, which is able to deliver asset compliant transactions over physical distributed shard or partition in a multiple collection table environment. What does this mean? We are able to have a database distributed between one part in Australia, one part in China, one part in Russia, one part in London, one part in New York, one part Tokyo. You choose it. You have a global distributed database, and we can guarantee transaction over one single database that way distributed. I'm not aware about any other vendor is really able to do that one in that context. There's a lot of discussions about CAP theorems. Obviously, MongoDB is a CP database in that regards, and which is different than the asset compliance, but people mix that happily up. Trillions of US dollars are processed by MongoDB. They're e-commerce systems. Literally, I heard a number of 80% of the e-commerce baskets are running on MongoDB, and I was a little bit like wondering, but when I see which vendors are utilizing actually MongoDB under the hood in the e-commerce space, and when we look into the payment infrastructure, how Nets runs multi-million transactions a day alone on credit cards, and you really measure this one up, you look into banks like BNP, you look in banks Santander, these are all financial institutions, these are just 3 of my clients here in Europe, then you really fast come up with huge amounts of money which are operated over MongoDB today. And on the other side as well, government services rely on MongoDB as a system of record. Healthcare, immigration, tax, and well, there are other services too. When we take a look, one thing what the cloud vendors tell you today is, well, we can make your life easy. We do a lift and shift. We move the stuff out, but I call this world of pain reloaded. You have a problem with infrastructure today. You have a large amount of different data stores. And when you move the stuff to the cloud in a lift and shift, you just replicate the environment. You can may say, yeah, but I simplify the physical infrastructure a little bit, but the software problems, which are much more expensive in maintenance than the maintenance of the pure hardware you have right now in the data center, is still given. So you replicate the complexity, you have the same API problems, you have the same siloed environments, you have the same data duplication, you have the same dependencies, and worst case, if you do this move to the various vendor-specific, cloud vendor-specific systems, which are little different in every single case, you have a high login rate. It's very, very hard to move from a Dynamo on AWS to a different system on Azure or SQL Server. This is not easy. When people say, yeah, I can always move, it's just like a drug addict. I can always stop just one more time. We see a little bit a better way. I call it move and groove. So obviously this is a little bit ferocious as well. It's not that you can move everything magically over to MongoDB, and probably you won't. But we see people looking into 80% of the infrastructure, and then you have suddenly the freedom of how you store your data. You can move between the platforms. You're not locked into one or the other cloud vendors. You can start optimizing and abstracting your data structures. You get better into the microservices world. There's no lock-in. You desilo your data. You have the data duplication removed. You have no more divergence and transformation challenges. So it cleans it up. Now, is this the most simple approach? Maybe not. Is this 100%? Absolutely not. Most cases I see 70 to 80% is a realistic number which can be moved quickly. 20% is some legacy stuff which you don't want to tackle. This leads then to the following very simple picture. On one side, you have the applications. These applications can be either having own databases or are actually system of record application instances. And they connect through a very, very broad number of different connectors, what we have available. Modern people love the Kafka, obviously, but as well, we have clients who use our standard APIs and programming interfaces and have the infrastructure with CDC and the classic XLO. All that stuff is punched into our real-time operational database, which scales out literally unlimited. I have not seen a limit yet, to be very blunt. The largest systems I heard about and seen about is about 2 petabyte. Common sense is half a petabyte is quite commonly implemented. Clients with 150 to 200 terabyte are really run-of-the-mill today standard implementations. Additionally, you have then the analytics data in the workload isolated nodes, part of the same database, no data duplication. And then you can utilize directly the Atlas Online Archive to offload data into a tiered storage environment. and the long-term retirement into the data lake plus search. So this is one platform for you. This is not, oh, I need 5 different system managers. It's one system to manage the data in, the data flows through the infrastructure as you need, as you see it fit, is centrally managed, and then you have any application, any connectivity into those data for different purposes and follow-up applications. So the most left and the most right side have probably a lot in common, can be actually the same application, it's just simplified from the look and feel here. Key is the flexibility, what we give you here. You have the really choice of any part of data movements and data structures in that environment. And then, of course, coming in things like data science, AI, and machine learning, which I'm personally very interested about. We see a lot of real-time use cases. We see a lot of cases where people ask us today, yes, I have my Hadoop system, but my data are 24 hours old and stale. Or I need under 1 second data and my Hadoop is several minutes late. And I need to pre-compute because otherwise the data don't get ready for the flow inside of a process. We do a lot of work with Iguazio, for example, as a good vendor example, who have a really, really nice data platform complementing MongoDB Atlas as well as on premises. And in this case, we have the response times up to 50 milliseconds for a whole round trip from data coming in through a sensor, through an e-commerce site, through the system, transaction or bucket is going into the database, data get analyzed, and next best offer is generated. 50 milliseconds. That's real time. We're hitting then, as a result, normally requirements coming out of business, operations, and development. This is very important. On the business side, people really looking these days for the transaction performance. It's not good enough anymore to have the 2-second end round trip discussion time. We have clients like ANZ Bank who moved down from a 5-second to 3 millisecond transactions throughput for their payment infrastructure. Now you may say, well, if it's set payment takes 3 seconds or 3 milliseconds or 5 milliseconds, doesn't matter. Well, it does, because the overall time and the throughput and the system infrastructure time are critical. We're working with our partner Icon solution in that space as well, where there's a cool example of a system able to deliver 100 transactions a second, full payment transactions, so not database transactions. And the whole infrastructure costs less than $25,000 a year in operation, fully redundant, fully high available, 24/7. Which brings us to the next point. Ultra availability is a point by now. High availability is yesterday. High availability is you have maintenance windows. We have no maintenance windows. We have clients running uptime for 6 years without the blink of an eye, rolling updates, major release changes. We had a discussion with CIO on group level of BNP who thanked us for 2.5 years operation of their payment solution without a single second downtime. That is what is expected from the business, plus the consistency and the security and all the services around that one. The operations team coming from a different side, they want robustness. They want the VW. They want to have a system running in any form and shape, absolutely simple. They want to have cost-effective, low TCO services, monitoring KPIs to check that the SLAs are hit. And the development teams obviously want agile, adaptable programming, elastic computing. They don't want to think about the sizing upfront. They don't want to design the solution around the database size. Instead, they want to focus on the code, the optimization for the client, the workflows, the line of business requirements, and the rest is taken care of in the backend. And obviously, there's by now a large number, as you can see, skills out there, not only people who run through MongoDB University, to be fair, there's a lot of people out there who self-skill as well. That was all, and I thank everybody for listening this morning, and I hope you guys still have a really good conference.